Hello everyone, welcome to my YouTube channel CNC for TDM. Today in this video I am going to explain system of tolerances. IS 919 1965, the standard system of tolerances. Uh, if you see in this diagram, this is these are all representing holes. Holes are represented by capital letters. These uh, figures by hatching lines A, B, C, D, these all figures, these are for holes. Whereas these dark figures, these are for shafts only. So in this figure, this is our zero line here. Zero line means it is basic size. And these are all deviations. If you see A is a hole, so here lower deviation up to this point, then this is upper deviation, and this is tolerance between lower deviation and upper deviation. This difference, it is called tolerance here. So all the holes from A, B, C, like this, A to H, these are A to Z, oversized hole. Oversized means these deviations are in the plus size only, plus side. Uh, if a diameter is 6, it will be 6 plus 0.02 plus 0.05, like that. So both the tolerances will be in plus side. So A to G. And H is used for hole, and small h is used for shaft whose fundamental deviation is 0. For H, this fundamental deviation is 0. So that means for H, deviation is plus 0 and plus say 10 micron, 20 micron, whatever. It is in plus side, and for shaft minus 0, minus 10, 20, 30 micron, like that. So H, so after H, then it is reversed like that. Then these are undersized hole. P2ZC, all undersized hole. And similarly for shaft, after H, this P2ZC, these are oversized shaft, like this. A to Z, undersized shaft, and then M to ZC, these are oversized shaft. So these fundamental deviations are A to Z. Some letters are not included, like I, then J, L, O, Q, and W. So these letters are not included because I is confusing with 1. So, and instead of J, JS is taken here, and L is not, it is for angle sometime symbol, and O, it is confusing with 0. So Q is also not taken like that, and W, if it is reversed, it may be M, like that. So these letters are not included, and other included are ZA, ZB, ZC. Then total deviations are 25, fundamental deviation, for 25 for holes and 25 for shaft. Okay, so here it is written here basic shaft. What is basic shaft? Basic shaft is when upper deviation is 0. Maximum limit of the shaft, that is shaft H. H is here upper deviation is 0. So similarly, lower deviation is 0 in case of hole. So H is the basic shaft, like that. So if you see here in this figure, uh, here it is soft and this is hole. This diagram is side view, this is the hole and this is soft. And this area, it is tolerance zone. This is called tolerance zone, like that. This is the tolerance zone of the hole and this is tolerance zone of the shaft here. And this is zero line. Zero line means basic size. So from the basic size, we define all deviations. So if you see here in the shaft, it is upper limit, this size upper limit, and here it is lower limit. So from upper limit to the basic to the zero line, it is called upper deviation. What is upper deviation? Upper deviation is that deviation which defines tolerance zone, which deviation is near to the tolerance zone. So it defines tolerance zone start from here. So this deviation is upper deviation. And lower deviation, this minimum size of the shaft. So this is our lower deviation. This is lower deviation here from the zero. Similarly, in case of hole, if you see, upper deviation is maximum size of the hole. This is upper deviation. And lower deviation is from zero line to this minimum size of the hole. So lower size is here lower deviation, whereas in case of shaft, if you see, a lower deviation is the small size of the shaft. So this is lower deviation. Here it is upper deviation. And what is fundamental deviation? For this here in case of shaft, this upper deviation is fundamental deviation. Upper deviation is fundamental deviation, and whereas in case of hole, it is lower deviation. Lower deviation is fundamental deviation. So which is very near to the basic size, that deviation is fundamental deviation, which defines the tolerance zone. That's all. So this way, if you see in this figure also, here this is given ES and EI. ES is upper deviation and EI is lower deviation. In case of hole, if you see here, so this is your diameter D. D is the basic size, and here it is EI. This is lower deviation and ES is the upper deviation. Similarly, in case of shaft, if you see here, this is EI, this is lower, and ES is upper deviation. Okay. So, and one more thing is, this is it was basically IS 919/1965, and it was revised, and this revised version is IS 919/1993, and it is very equal to this ISO 286/1988. Okay, so after revision, two tolerance grades were added, IT 17 and IT 18, international tolerance grades. These two grades were added. Otherwise, all the things are same in previous standard also. So this is our revised system of tolerances. Okay. And if you see now, these are tolerance grades. Tolerance grade basically how these are the fundamental deviations for units. I is the unit for fundamental deviation. These are tolerance grade 85, 6, 7, 8, 9, 15, 16 like that. And it is given here, this is standard tolerance 7i, 10i, 16i, 25i. These are all, I is the unit and 7i is the standard tolerance. If you multiply this I by 7, then this tolerance is calculated in grade 5. So 10i is for grade 6 like that. So if you see here, we are taking one example. One example is, say, diameter 6H7G6. This is our tolerance class. We have to define this. What is the tolerance class? Basically 6H7G6. What is here 6? 6 is the basic size. Basic size. H is the fundamental deviation for hole. H is defined, hole is defined by capital letters. So fundamental deviation of holes are defined by capital letters. And 7 is the grade. Okay, grade of the fundamental deviation. And G, small letter G, it defines fundamental deviation of the shaft, G. And 6 is the tolerance grade. So we have to calculate how much is the tolerance and what type of fit it is. Say, now first of all, what we have to do is 6 mm, where it lies in the step of 3 to 6. So D is, how we calculate D? What is basically fundamental unit is given I. Formula for I is equal to 0.45 cube root D plus 0.001 D. So what is D? D is the geometric mean of the steps. So this step is 3 to 6. If you see here, these are the steps given here. These are the steps 1 to 3, 3 to 6, 6 to 10, like that. These are the steps. Okay. And D, what we have to do is, so D we have to calculate by geometric mean, like this. Okay. So here, this D is 3 into 6 under root, it becomes 4.24 mm. This is D. Okay. So here tolerance unit is calculated 0.25 cube root D plus 0.001 D. If you calculate this like that, 001 into D is 4.24, then I is calculated here 0.7327 micron. Micromillimeter means microns. Okay. But the limit of tolerance for hole H7. Hole H7, if you see here, 7 grade this, and tolerance is 16i. So you multiply this unit by 16. Okay. So how much it will be? 16i, 16 into 0.7 micron, it becomes 11.72 or say 12 micron. In whole figure, it is 12 micron. So 12 micron is the standard tolerance that we have calculated like this. And the fundamental deviation for hole is 0. For H it is 0. Fundamental deviation is 0 and tolerance is 12 micron. Okay, if you see here in this diagram, this is 12 micron. Tolerance we have calculated, it is 12 micron. This is our basic size, 6 mm here, 6 mm, and this is our tolerance zone here, and 12 micron is the tolerance. 6.012 will be the maximum size and minimum size will be 6.000 because fundamental deviation is 0. So, and this is the tolerance. So this we have calculated for H7 hole, H7 and 6 mm dia. So these are the tolerances. Now next what we have to do is, now we have to limit of tolerance for G6 shaft. We have to calculate for G6. For G6 it is 10i. if you see here in diagram is here in this table, so for 6 it is 10i, IT6. So tolerance grade 6, it is 10i is the tolerance. Okay. So here 10i means 10 into I we have already calculated 0.7327. So it becomes 7.3 or say 8 micron. So tolerance is now 8 micron for the soft. Okay, but fundamental deviation for G soft is minus 2.5 into d power 0.34. If you see here, it is given here. These are the for soft D, E, F, G. These are the fundamental deviations D, E, F, G. This is D, E, F and G. For G it is minus 2.5 into d power 0.34. Okay. So now we calculate this fundamental deviation for G minus 2.5 into d power this. So if you calculate, it comes minus 4.085 micron or say minus 4 micron. So fundamental deviation is minus 4 micron and tolerance is 8 micron. Okay. How we represent it on the diagram? Let us see here. So this is 4 micron, minus 4 micron. 4 micron is the fundamental deviation, and then starts tolerance. And tolerance is 8 micron. So here, this is 8 micron tolerance. So size becomes this size. If you subtract 4 micron from 6.000, it becomes 5.996. Okay. Then again you subtract 8 micron from this, it becomes 5.988. So these are the upper and lower limit of the soft. And we have calculated this also for hole also. So now how much is the maximum clearance? Maximum clearance is maximum size of the hole minus minimum size of the shaft. That will be the maximum clearance. Okay. And my maximum size of the hole is 6.012. And minimum size of the shaft is 5.988. It is 5 here. 5.988. If you subtract this, it becomes 0.024 mm. That means 24 micron. 24 micron is the maximum clearance. And minimum clearance, how much is the minimum clearance? It is minimum size of the hole minus maximum size of the shaft. So minimum size is 6 only, and maximum size of the shaft is 5.996. So 6 minus 5.996, 6 minus 5.996, it becomes 0.004 mm. That means 4 micron. So clearance now, clearance is 4 micron to 24 micron. So this type of fit is clearance fit. It is a class of fit. So clearance fit. So now I have calculated how to calculate this with diagram. I have explained you. I think it may be clear to you now. Thank you for watching. Please like, share and subscribe. See you in next video soon. Thank you.